Hi guys, I'm Eddie, and today I'll be teaching work and energy. First of all, we'll start off with work. Work is when you apply a force to an object over a certain distance. For example, if you have a block here and you do a force like this and it goes a displacement d, then the force does work on the object. However, if you have a block and the force goes this way, like if you're pulling it with a string, so it'd be force tension, and the displacement goes this way still, then the work you'll do is force times distance times cosine theta, because on the force, it has components, the horizontal component and the vertical component, where the horizontal component, because this is the angle theta, the horizontal component is force times cosine theta, and the vertical component is force times sine theta. And in this scenario, the horizontal component is doing the work. So it would be force times cosine theta times the displacement. And you can see that the angle for positive work, which is when the force is giving the block more energy or more work, it would have to be from 0 to 90 degrees, not negative 90 degrees. And if the work is 0, then it would be when the angle is 90 degrees. And when the work is negative, it would be when the angle was between 90 degrees and 270 degrees. And kinetic energy, first of all, the net work done on an object is equal to the force times the distance. And in this case, when it's the net work, you have to have you have to write the net force as well. And the net force is equal to the mass times acceleration. So you would write mass times acceleration times the displacement. And by using the kinematic equation number 5, you can write V final squared is equal to V initial squared plus 2 times the acceleration due to gravity times the distance. And if you're trying to solve for the acceleration due to gravity only, then you can write V final squared minus V initial squared is equal to 2, divided by 2 over the distance. And then you can plug it into this equation and write mass times Vf squared minus V initial squared over 2d, and then times d. And you can cancel out these two. And then if you do the math, you can get the work net is equal to 1/2 times m final squared minus 1/2 times m times the initial square. And this is also equal to the change in kinetic energy. And the kinetic energy would be 1/2 times mv squared. So that brings us to the work energy theorem, which is what I said before, the work net equal to change in kinetic energy. And this is another way to solve for the work if you don't want to write, if the force on a block is changing, then you can instead just use the kinetic energy change to find the work net instead of finding like the force times distance of each interval. And then potential energy. Potential energy is the energy due to position. And in the diagram, you can see that the car is on top of the mountain or hill, and it has potential energy. So you can write potential energy is equal to mgh, which is the mass times acceleration due to gravity times the height. So the further you go up and like the higher you get, then the more potential energy you have. And finally, it's the conservation of energy is when energy is transformed from one energy to another. And such as, for example, if you have a ball on top of a mountain or hill, it originally has potential energy. And as it's going down the mountain, it's gaining velocity or speed, and it changes, it's transforming to kinetic energy. And this is how it's transforming or transferring to different energies. So in the beginning, it has potential energy and no kinetic energy. So by using the equation P, the gravitational potential energy initial plus the kinetic energy initial is equal to the potential energy final plus the kinetic energy final. So you can see that in this situation, it has initial potential energy and has zero kinetic energy since it's on top of the mountain and not moving. And in the end, the final potential energy is zero, while the kinetic energy final is not zero. So we write mg times h initial is equal to 1/2 mv final squared. And you can use this equation to find the velocity or the height based on if you know the mass already. Do you guys understand? Okay. And you can start with the problems now then. So you guys can take 2 minutes to do the first problem. Okay, we can start now. Um, so to do this question, it's asking for the potential energy, right? So we know that the potential energy is equal to the mass times acceleration due to gravity times the height. So if you plug the things you have in, for object 1, you would get 4 times g times 3. And for object 2, you would get 2 times g times 6. And if you do the math for that, or just like these two and these two, you get the object 1 is 12g and object 2 is also 12g. So it would actually have the same potential energy, which is C. Do you guys understand that one? Okay, so we can move on to question 2 then. And remember that kinetic energy is 1/2 times mv squared. All right, you guys can have 2 minutes to do this question. Okay, I'll explain this question now. So in this question, it's asking you the ratio between the initial kinetic energy of the bullet and the kinetic energy when the bullet leaves the block, which is also the final kinetic energy. So the initial kinetic energy is just KE, which is just 1/2 mv squared. And the final kinetic energy would be 1/2 times m times v over 2 squared. Because after the bullet penetrates a wooden block, it loses half its velocity. So you have to divide it by 2. So if you solve that, it would get 1/2 times mass times v squared over 4. So now if you write it like 1/2 times mv squared over 1/2 times mv squared over 4. Cancel out the 1/2 and m, and you would get v squared over v squared over 4. And if you divide that, you would get 4 over 1, which is d. And okay, so problem 3. You guys can have 2 minutes to do this as well. Okay, I'll explain the question. So it gives you the mass of the book and the height of the bookshelf. So you already know that the mass is equal to 2 kg. The height is equal to 2.3 meters. So, and it's asking you to find the work. So you could use potential energy is equal to mass times acceleration due to gravity times height. And you can get 2 times 9.8 times 2.3. And that would give you around 46 joules. Oh yeah, you can also use forces to do this by using the net force. We can use work is equal to force times distance, and you can use the net force is equal to force due to gravity plus the force equal to lift, and this is equal to 0. So you would get the force due to gravity equal to the negative force due to lift if you subtract it. And the force due to lift is equal to negative mg, because that's what this is. So you get -2 times -9.8 is equal to 19.6 newtons. And you know the distance is 2.3 meters. So you get around that as well. But using potential energy would be easier. You guys understand that one? Okay, so you can do question 4 then. Okay, I'll start explaining the question now. So this question goes back to the work energy theorem, which is work is equal to the change in kinetic energy. And it's asked for the total work done. So we know that kinetic energy is 1/2 mv squared. So you're trying to find the final kinetic energy minus the initial kinetic energy. So you would write 1/2 times m times v final squared minus 1/2 times m times v initial squared. So you would write 1/2 times, you know the mass is 1,500 kgs, and then times the final velocity, which is 50 meters per second, so 50 squared, and then minus 1/2 times 1,500 times the initial velocity, which is 40 squared. So that's how you get the net work done. And you can see right here that the answer is 675,000 joules. And you can move on to question 5. Okay, so I'll explain the question now. So it's asking for the final velocity right before it hits the ground. So you would have to use the conservation of energy in this situation, which again is the initial potential energy plus the initial kinetic energy is equal to the final potential energy plus the final kinetic energy. And since a rock is dropped in free fall from some height, you know that the kinetic energy, the initial kinetic energy would be 0. And if it's falling down, the final potential energy would be 0. So you're given initial potential energy is equal to the final kinetic energy. So you would write m times g times h initial is equal to 1/2 times mass times v final squared. And in this problem, you're only asked to find the equation. So you can cancel the masses. And so you're given v final squared over 2 is equal to g h. So multiplying by 2 on each side will give v final squared equals 2gh. And square rooting on both sides would give you v final equal to root 2gh. So it would be this one. Don't understand. Okay, so you can have 10 minutes to do these next 5 questions, and then I'll explain it after. Okay, I'll start explaining the first few questions. So, in the first question, it asked it asked for final velocity, and you're given the height and gravity. So you can use the conservation of energy. So you already know that the initial kinetic energy would be 0, so you can just keep the potential energy, and the final potential energy would be 0. So you can just have kinetic energy. So you would write mgh initial is equal to 1/2 mv squared, and you try to find v in this situation. So canceling out the m, you can write g times h equals 1/2 v squared, and v is equal to root 2gh, and then plug in what you have, and you get the final velocity. You guys understand that one? Okay, so the next question. A sled is initially given a push up a frictionless 25-degree incline. It reaches a max vertical height of 1.4 meters. What was its initial speed? Does anyone have the answer to this question? Okay. Um, so this question is like the other question, and it's trying to give you the 25-degree incline to mess you up, but you would still use the conservation of energy. And like the other question, it's still going to be 1/2 m final squared is equal to m times g times initial height. So you can cancel out the m again, and oh wait, actually in this situation, it would actually the final velocity, so it would be m g h I plus 1/2 m v I squared equal to m g h final plus 1/2 m v final squared. Since it's starting from the bottom, the initial potential energy is actually 0, and at the top, the final velocity, kinetic energy would be 0. So you actually have 1/2 m v initial squared is equal to the final potential energy. So again, you can cancel out the mass and get the v initial equal to 2gh. And then again, plug in to get the v initial. Okay, so question 8. This one's also fairly simple. It says Ryan pushes a 14 kg filing cabinet 2.1 meters across the floor, doing a total work of 88.2 joules. How much force is he applying to the cabinet? So you know that, so it looks like this. So it's pushing the force like this, going distance this way. And it's the force in this displacement. So it wants the force in this situation, and you know the distance is 2.1 meters, and the work is 88.2 joules. So you can use the equation work is equal to force times distance, and you get force, you get 88.2 joules is equal to force times 2.1, and force would be equal to 88.2 joules over 2.1 meters, and you would get the answer. For question 9, it asked a cat knocks a 0.01 kg toy mouse across the floor with 3 newtons of force, and the cat did a total of 12 joules of work. So just like the question we just did, except this time you're trying to find the distance. And again, it gives you the mass, which is unnecessary. So it gives you can use equation work is equal to force times displacement. And you get the work is 12 joules and the force is 3 newtons. And so you get D is equal to 12 over 3, which is 4 meters. And finally, question 10. First, you're given that the mass of an arrow is equal to 92 grams. But in physics, we usually change the 92 grams to kgs, so it would be 0.92 kgs. And it exerts an average force of 112 newtons. And over a distance of 75 centimeters. And again, we would change that to meters, so it would be 0.75 meters. So if you're trying to find the speed of the arrow as it leaves the bow, then you would probably want to use the work is equal to the change in kinetic energy, which is the work energy theorem, because you're given the force and the distance and just given the mass. So the work would be equal to 112 times 0.75 because it's force times distance. And for the kinetic energy, it's 1/2 times m v final squared minus 1/2 times m times v initial squared. So you know the mass is 0.92 kilograms. So it'd be 1/2 times 0.92 times v final squared minus 1/2 times 0.92 times v initial squared. So you want to find the speed of the arrow as it leaves the bow, which is the initial velocity. Wait. So actually, it would actually be the final velocity because the initial velocity would actually be 0 since it's the initial velocity would be 0. So it cancel out this one. So you get the work is equal to 1/2 times 0.92 times v final squared. And then you can just solve for v final. Does everyone understand? Okay. So you can work on questions 11 and 12. Okay, so I'll start putting the question out. So you get that the potential energy is equal to the mass times acceleration to gravity times the height. It's 0.25 times 9.8 times 10. And you can get 24.5 joules from it. So it's asking you what the max height will be after it hits the ground 4 times. And you're given that it loses 10% of the kinetic energy every time it hits the ground. So you need to do 1 minus 0.1 every time for 4 times, which should just be like that. So, and it'd be 0.9 to the power of 4. So we need to write oh wait, I just realized that I forgot part of the question. Wait, you guys can like skip this question then. You guys can do the next question instead. Just do question 13 then. Just 13. All right, so since it's almost 7:30, I'll just explain this question real quick. So basically, a runner arrives at the bottom of the hill, runs up the hill with a constant acceleration until he reaches the top, then runs at a steady pace along the top of the hill. When are the kinetic energy and potential energy at the greatest? So does anyone want to answer first? Okay, so for the potential energy, it's at its max when the man is on the top of the hill because it has the max height. And so it would be the max height at the top of the hill. So the potential energy would be at its greatest at the top. And then the kinetic energy is to find the greatest amount, since velocity is the main reason to find the greatest amount of kinetic energy. Since he runs up at a constant acceleration, he gains speed as he's running up the hill. So he also has the max kinetic energy when he's at the top of the hill. Since at the top of the hill, he has his max velocity. So that's it for this week. Thank you for coming and have a good week.